For our research article, we focused on a study where researchers were curious whether the hallux, also known as the great toe, had any impact on balance control, specifically under different conditions. We know that balance depends on controlling pressure under the foot and the ankle, and that the great toe can help stabilize the body, especially when tasks are extra challenging. The research question in mind was whether constraining the great toe changes static and dynamic balance performance. For our procedures and methods that our researchers chose, there was 30 young women that were recruited around the ages of 22 years old. They also had no sporting history, but they were used in a repeated measures design where everyone did both toe conditions, unconstrained and constrained. There was 4 conditions and the order was randomized. They did their set of these 4 balance tests, but rested 10 minutes between before repeating the full series with the other condition. The 4 conditions chosen were 2-legged stance with eyes open and closed, single-legged stance with eyes open and closed, rhythmic weight shifting, and target reaching. Next, the results will show which balance tasks depend more on the great toe.
So for the data and results part of our research that we did, we were able to see what was measured and the main findings. And what was measured was the balance performance at a sway velocity, which was degrees per second. And the device that was used to measure that was the Smart Balance Master, tested during the single leg standing, the forward and backward weight shifting, and the static and dynamic balance tasks performed by all of the participants. In this, we have our main findings, which shows that the sway velocity was higher when the great toe was constrained and splinted, and is less stable when the big toe was restricted against the other toes as well. The biggest differences were seen in the single leg standing, the forward and backward weight shifting, and then actually what showed no difference at all was the standing on 2 feet. That was a good thing, I feel, to put in, though, to show the difference between when it is constricted and it's not constricted. However, it's shown in the figure 3 graph that was given to us from the research paper, and it just shows that the sway increased in every condition when the big toe was restricted. So the effect wasn't random. It happened across both legs and both eye conditions, and the balance was worse with eyes closed overall, because this shows that the vision helps with stability, and without it sway increases. And then last thing is the highest sway happened when eyes were closed and the toe was constrained, which just because of that combination, it seems to make balancing the most difficult. So in conclusion, we can find and say that the toe being constricted, eyes closed, was worse for the participants and their balance.
After analyzing this article, we could kind of come to the conclusion that the great toe does have a great effect within movements, but I also wanted to touch up on how it alters the kinetic chain within movements, specifically within the ankle, hip, and knee joints. A good example within this article is how when they had dorsiflexion within the great toe, that they noticed a great more deal of hip activation within the left or right sway of some of these exercises. Another thing I wanted to touch up on within this article is how they test a very small group of individuals within the population, which could kind of hinder the application of this article to the greater population, because it only tests females of a specific age and background of medical history. And the last thing I wanted to touch up on was the different body types, how different body types would have a greater effect on the great toe length, which making it smaller or longer, which can have an effect on dependability. However, as stated within the article, further research can really help and determine why postural sway increases during dorsiflexion constraint.
So for our main takeaways from our presentation, for what we found was that restricting the great big toe increased center of pressure sway velocity, indicating worse balance performance. The great toe contributes meaningfully to maintaining postural stability during sciatic and dynamic balance tasks. The study used within subject repeated measures design, strengthening the comparison between toe-free and toe-constrained conditions. Results apply specifically to healthy young women tested in a laboratory setting. A key message for our presentation was that the great toe plays an important role in balance, but it is not the only factor responsible for stability. And then for real world applications, footwear that excessively restricts the big toe may negatively affect balance performance. When practicing balance training, maintaining toe mobility may support a better postural control. Findings may be relevant for athletes, rehab settings, and footwear designs. This study was conducted in a lab using a splint and 30-degree dorsiflexion to stimulate toe restrictions. So the results don't directly prove effects on the real world falls or injury preventions, and that's what we found for real world applications.